how do we factor if there's decimals or fractions? And so the idea that we're going to use is we're going to get rid of the decimals and fractions so that we can factor like we factored before. So in the first one, in A, the fractions, or sorry, the decimals that I have are 1.5 and 0.5. Can you tell me a number that you could multiply by to get rid of those decimals? What would I have to multiply x squared minus 1.5x plus 0.5? What's a number I could multiply by to get rid of all the fractions? There's more than one right answer. Yes. I could multiply by 2. You could multiply by 10. You could multiply by 100. The bigger the number is, the harder the math later on will be. So if you can find that smallest number, in this case multiplying by 2, that would get rid of all of those decimals. Now mathematically, if you have something and you multiply it by 2, is it the same as what you had before? Like if I have $10 and I multiply it by 2, I now have $20. I've changed what it's equal to. And so what we're going to do in this situation is we're going to multiply by 2, but at the same time, we're going to multiply by half. What does that do? Nothing. Multiplying by 2 and multiplying by a half, that like cancels each other out. But what's going to happen here is I'm going to take the 2 and distribute it and leave the half out in front. So my expression becomes this half stays out in front, and when I multiply the 2 through, I get 2x squared minus 3x plus 1. Technically, if we want to get fancy, what I just did was I factored a fraction out of the whole thing. But sometimes factoring a fraction out of the whole thing is hard to visualize. It's easier to see that it would take timesing by 2 to get rid of all the decimal places. And so multiplying by 2 and multiplying by a half is like multiplying by 1. It doesn't change what the answer is, it just changes what it looks like. And by changing what it looks like, so the blue that I started with now ends up like this with a half in front, I can now factor the inside here. The only way I can get 2x squared is 2x and x. The only way you can multiply to get 1 with whole numbers, 1 and 1. Can my outside and my inside ever be negative 3? Yes, if they're both negative. And we have now factored this completely. Hello?
Could you please have...
In part B, here I'll just, oh, that's fancy. That's nice. There, I'll just move part B down to there. In part B, we have a fraction. So part A, we had a decimal, and we found out that we could multiply by 2 to get rid of that decimal. In part B, we have a fraction. Once we're done this, yeah. So what would I have to multiply all of this by to get rid of the fraction of the 3 on the bottom? This is on page 172. I'd have to multiply by 3. But if I multiply by 3, that changes what this is equal to, so I'm also going to multiply by 1/3. Because multiplying by 3 and 1/3 at the same time is like multiplying by 1. But now if I distribute this 3, I will successfully get rid of the fraction. It'll become 3x squared minus 17x minus 6. And now we've got a trinomial inside that we can factor like before. How do I get 3x squared? What would my first ones have to be? 3x and x. And now for my last ones. I need something that multiplies to give me 6. So my outside and my inside make 17. Sometimes when trying to figure this out, the best way to try to figure it out is to just try one at random and see if it works. So what two numbers multiply to give you 6? 2 and 3. So if I put 2 here and 3 here, what's my outside? It's 9. My inside is 2. Does that make 17? No. So 2 and 3 doesn't work. 6 and 1. So if I try 6 here and 1 here, my outside is 3. My inside is 6. 3 and 6 makes 8 or 9. Whew. Doesn't quite work. But if we did 1 and 6, outside is 18, inside is 1. Does that make 17? Yes. To get a negative 17, I would need a negative 18 and a positive 1. Quick multiplication shows, check, this is correct, and so this is the factored version. So try some of these on your own. I can scroll. How high do you want to go? Question A, yes.